Welcome back. In the previous video, we have learned about the k-means algorithm, the working of k-means algorithm step by step. In this video, I'm going to learn teach you about inertia and elbow method. What are these? In the previous video, we have selected randomly the k value as 5. We have randomly selected the number of clusters. But the standard way of selecting the k value is inertia and elbow method. Using these two methods, we have to find the optimal value of k. Optimal value of k. That is, we have to find the optimal number of clusters. We have to find the optimal number of clusters using these two methods, inertia and elbow method. So what does inertia stand for? Don't worry about WCSS. It is nothing but within cluster sum of squares. This is the formula of inertia. I will teach you. First, let's understand what the inertia is. What is inertia? Inertia, we can define it as inertia measures how compact the clusters are. How compact the clusters are. How compact the clusters are. What is the meaning of compact here? The compact is nothing but how close the data points, how close the data points are to centroid in a cluster. It will check the distance between the data point and centroid. If they are very close, this is highly compact. If they are far from the centroid, these are loose compact. So I want to visualize this. Let me visualize this. This is my cluster 1 with centroid 1. Okay. And this is my cluster 2 with data points. This is one cluster and this is one cluster. This is centroid 1 and this is centroid 2. If you see in the cluster 1, the distance between centroid and data points is far, is not close, is more. The distance is more. So this is loosely compact. That means high inertia. High inertia. And if you see, the data points are very closely to the centroid. They are at very close distance to the centroid. That means it is highly compact centroid. That means less inertia. That means less inertia. So we have to find out using inertia how compact the cluster is. If it is highly compact and less inertia, then that is the optimal k. Is the optimal k value. That will be the optimal k value. Okay. The formula to find the inertia is WCSS. WCSS. WCSS stands for within cluster sum of squares. Within cluster sum of squares. The formula is WCSS is equal to summation of I is equal to 1 to k. Summation of x belongs to summation of x belongs to Ci. X minus mu I whole square. Okay. K is number of clusters. K stands for number of clusters. Ci is cluster, whether cluster 1, cluster 2, or cluster 3 to n number of clusters. X is a data point. X is a data point, and mu I is centroid of a cluster. Centroid of a cluster. So we have to calculate the distance and square it. Okay, we have to calculate the distance and square it for every data point in a cluster. We have to calculate the distance between every data point and centroid in a cluster. Okay, a cluster, then square it and add it. Then square it and add it. I will show you with an example. Consider we have a cluster. We have a cluster of 3 data points. 3 data points A, B, and C. And centroid is C1. For every cluster, there will be one centroid, that is C1. Now we have to find the distance between every data point and centroid, that is distance of A comma C1. Then square it. Then distance of A comma B comma C1. Then square of the distance. Then distance of C comma C1. Then square it. And then we have to add all this distance. Then we have to add it. That's what here summation stands for. Okay, square it and add it. This gives us this is cluster 1. Okay, this gives us the WCSS of cluster 1. Cluster 1. Then repeat same thing for cluster 2. Can do the same thing for cluster 2. Number of data points, the distance, calculate the distance between the data points and centroid. Square it, add it. It gives the WCSS of cluster 2. WCSS of cluster 2. We have 2 clusters, then we have 2 WCSS of cluster 1 and cluster 2. We have 3, we have to do it 3 times. Then what is the inertia then? Inertia is equal to total WCSS, that is WCSS of cluster 1 plus WCSS of cluster 2 plus so on plus WCSS of cluster n. We have 2 clusters, 2, 3 clusters, 3. So we have to add all of this. Okay, all of this, and we get the total inertia. And we have to observe a point here. See, we have to observe a point. If there is only one cluster, that is K is equal to 1. Okay, we have this data set. We have this data set. These are our data points. These are data points. Okay. And we have only one cluster. We have only one cluster. Then obviously inertia is high. Inertia is very high. Now the K value is 2. Suppose now we will increase our K value to 2. We have 2 clusters now. then inertia will decrease because we are forming two clusters now. Suppose this is cluster 1, cluster 2. The compactness has increased, the inertia will decrease. And if we increase again, k is equal to 3, then we have three clusters now, 1, 2, 3, highly compact now. Now we have three clusters, 1, 2, and 3. That means inertia is decreasing. Inertia is decreasing. Now k is equal to 4. Now again, like 4 clusters, compactness increases, inertia decreases. That means k is inversely proportional to inertia. As the number of k's increase, the inertia goes on decreasing. Then when to stop? When to stop? What is our optimal value then? What is our optimal value of k then? Which k value you should select? At which k value you should stop, whether 1, 2, 3, or 4. When to stop? So here comes the elbow method. Here comes the elbow method. Elbow method is used to find the optimal value of k. Elbow method is used to find optimal value of k based on inertia. Based on inertia. It will find optimal value of k based on inertia. What logic it uses? Logic is very simple. Very simple. Choose the value of k. Choose the value of k where the adding more clusters does not significantly decrease the inertia. Choose the value of k where adding more clusters does not significantly decrease the inertia. Let me write it. Choose the value of k where adding more clusters does not significantly is important, significantly reduce inertia. Significantly reduce inertia. Let's consider an example for this. I have k value here. Okay? K value and inertia. Okay. And k value is 1. The inertia is 900. K value is 2. Inertia is 500. K value is 3. Inertia is 300. K value is 4. Inertia is 220. K value is 5. Inertia is 200. K value is 6 and inertia is 190. Consider this example with random k values. As k values have increased, the inertia has decreased. Now see, choose the k value. Choose the k value where adding more clusters does not significantly reduce inertia. Let's check here. When k value is 1, inertia is 900. And when k value is 2, inertia has become 500. So what is the reduced amount in inertia? By how much units inertia has decreased? 400. That is a significant decrease. Now compare, k value is 2 and k value is 3. That means 200 reducing inertia. Inertia has decreased by 400. Here inertia has decreased by 200 units. Now if you see here, inertia has decreased by 80 units. Inertia has decreased by 80 units. So comparatively less. Not much significant, but I think it is significant. But you have observed next k value is equal to 4 and k value is 5. Only 20 decrease, 20 units decrease in inertia. And here only 10 units decrease in inertia. So if you see this, adding this k value as 5 and 6, there is no significant reduce. There is no significant reduce in inertia. So I will choose k value as 4, the optimal k value as 4. Optimal k is equal to 4 for my k means algorithm. I will do 4 clusters. So this is how we use inertia and elbow method. I have done the practical demonstration. Same from the previous example, I have continued. Okay. I will calculate for k in range of 1 to 11. From k in range of 1 to 11. So it will use k is equal to 1, 2, 3 and up to 11. It will build the k means algorithm. It will fit the k model and it will find the inertia. See here, k means dot inertia underscore. This will give you the inertia values. If I display the inertia values, you see when k is 1, the inertia value is 400. When k is 2, the inertia value is 269. That means approximately 130. Approximately 130 units decrease in inertia. Now k is equal to 3, it is 157. So approximately 100 units. When k is equal to 4, it is 108. That means approximately 50 units decrease. Then k is equal to 5, it is 65. So again approximately 50 units of decrease in inertia. But you see the k is equal to 6, only 10 units. K is equal to 7, again 10 units. This is not significant reduce in inertia. Again k is equal to 8, 37. See, the values are not decreasing much. The inertia value is not decreasing much. So that means my optimal k value I should select here as k is equal to 5. Because after k is equal to 5, the inertia value is not decreasing much. There is no significant reduce in inertia. So I will select my k value as 5, optimal k as 5. I can show you in the plot itself. See, elbow method. If I do the plot, if I visualize the k clusters, these are x-axis is k value 0, 1, 2, 4, 5, 6, and this is the inertia value WCSS within cluster sum of squares. And if you see the graph here, at k is equal to 1, the inertia is 400. At 2, it has significant reduce. At 3, again there is significant reduce. At 0.4, there is again significant reduce. At 0.5 also there is significant reduce. But after 0.5, the line is, see, the line is almost, it is becoming a constant line. There is no significant reduce. It is constant now. Almost approximately it is constant. It is becoming constant. That means my k value, optimal k value is 5. So this will be my optimal k value. I have to form 5 clusters to build my k mix algorithm. So again I have built my k means model using clusters 5. I have specified here n clusters is equal to 5. So this is how you have to find the optimal value of k for k means algorithm. Thank you so much.